My name is Lucas Kradiger. I'm a principal engineer working on the data center and enterprise switching side. And I'm going to talk a little bit about fabrics and specifically do what we do in regards of EVPN in this. Now, we can talk about EVPN probably for hours. We do that at various occasions. And for today, I took one or two topics out of it. Let's see where we can go. One is something we call IRB, and who worked back in the times on the 8Ks? Very back? So yeah, we had that back there, right? Or the 2948 GL3, IRB was there as well, right? So IRB specifically is nothing else than integrated route and bridge. So we're going again down the path, or we're actually going that path already for the last 2 years. And for the last more than 12 months, we're running it specifically in VXLAN. And we run it in VXLAN EVPN to be even more specific. There's no slide. So I tried to use the whiteboard today. Let me know if you can read it. My handwriting is a little bit cumbersome, but I guess we're getting that going. So when you look traditional networks, what we did in regards of the routing instances, what have we done? We did some things like HSRP, VRP, GLBP, you name it, right? That was normally the case what we did. And we did that in a very centralized way. We had some protocol talking here, and then when we're going down into the what we called excess, or more fancy today in fabric terminology, leaf, we stick with L2 down here, right? So whenever we wanted to do routing, we crossed L2. We crossed L2, we crossed L2. And as you can see here, depending on however my layer 2 hashing was it in port channel, was it in VXLAN, wherever it was, we didn't really know where it goes, right? It could go left, it could go right. Now, let me see if we have another color somewhere here. Black, blue. Respectively, return traffic, if we now use two servers here as an example, it's my server 1. And let's do server 2 in blue. Nope. Come on, Brianna.
Oh.
So let's do server 2 in blue. We even could have completely asymmetric traffic patterns. And when we look at VXLAN, and I use a little bit VLAN and VNI respectively, this is basically in one way we use VNI 1, and the other way we use VNI 2, and we don't really know where the traffic actually was going whenever we route. So black and blue 2 routing place. In addition to that, all our state was pretty much centralized on one page. So that's where my ARP table was. And in order to get that even running, all of these boxes had to have the same ARP table, otherwise no routing, right? That's how we want to reach that guy, that default gateway in that case. On top of that, what was the normal amount of number of like these core switches or aggregation switches we had? Was 2, right? 2 was active. Did you ever went beyond 2? Yeah, we did with Fabric Path back in the time. We had 4, but then we ended up, right? It's 4 done. Or then you started doing some VLAN balancing and some other crazy stuff, operationally pretty difficult on the end. But that's what we had, right? Now, where we're going today and where we are today is actually down here. Forget the L2 only. Up here, forget the L2, L3 demarcation. We're going to move that stuff down, and that's why I said IRB, or integrated route and bridge. We're going to have L2 as well as L3 at this layer. So what we're actually doing up here is nothing else than having some routers underneath, which are creating my underlying network for VXLAN. So when we talk about tunnels, my VTAPs are here. Does that make sense to everyone so far? You can follow me? Sorry, I don't do it.
Moving the routing to the edge.
I do the routing as close as possible to the host.
Whereas in the old days, we used to do it at the top of at the root of the spanning tree.
I do.
We did layer 3 in the chassis at the root of the spanning tree.
Absolutely correct. And move away from a centralized approach
Yep.
into what we call a distributed approach or disaggregated approach.
Yep.
As with this approach, the ARP, which was very centralized and created my large tables and required some table spaces up here, move now also into this layer. So what does this mean? 100,000 ARP entries, when I looked at the data sheets, which switch can do it. Skip that, we go down here. Now what do I need down here in regards of ARP tables?
30,000, 25,000.
30,000, and I guess with merchant silicon, it's all over the way, right? We have it. It's there. Now, but we need also L3, right? So what we see a lot in this ASIC space out there in regards of merchants, a lot of VXLAN bridging there. But what we're missing is the VXLAN routing piece. So how do I get from my black guy over here, my S1 server, how do I get into my S2 server? That needs additional logic, right? So that's where the Cisco ASICs come into the play on the Nexus 9000 as the Merchant Plus strategy, where the 5600 with the Cisco ASIC are being present, and the Nexus 7000 with the F3 and also subsequent line cards coming out. So we're able to move all that down here in a very, very small form factor. If you need more ports, we can give you more ports, but the form factor can be reduced on that side. Now, just routing is not enough. Sorry.
Just to clarify something.
Go ahead.
The connectivity in the leaf in the spine, between the spine and the leaves.
Yes.
That's all layer 3.
Yes.
Right.
Yes.
IP routing, so it's stable.
IP routing,
Stable as we can
OSPF,
make it,
ISIS, BGP, you name it.
Yep. Doesn't matter
And
much, really.
we don't care on this, right? The functionality, what we call the VTAPs and VXLAN, what we call where we start the encapsulation, that happens down here. And this is just a transparent cloud to me.
So
I don't look at this.
And if we had bridging loops, we're limited to, if we were to have a bridging loop introduced from an external source, say, of some sort, like whatever, the impact is not going to take down the entire spine. It's only going to hit the layer that's having the troubles.
For the spine itself, it looks like traffic.
Yep.
Right. So when we want to mitigate bridging loops, we are acting down here. Mm-hmm. So we still use things like VPC to prevent all these spanning tree kind of related things.
Yep.
Spanning tree south is still there. So storm control, you name it, all these nifty
But
features.
we don't get if there is an event, we don't get a collapse of the root bridges because all the traffic has to cross the root bridge.
Exactly. We stay local. We contain the failure domain down to the leaf switch or down to the access switch, whatever you want to know it.
The blast radius is reduced effectively.
Yes.
Yeah. In a 3-tiered layer 2 design, the old traditional spanning tree, root of the bridge, the blast radius is everything that's connected to the core chassis.
So this is our blast radius.
Yep.
When we look in traditional world, this is basically our blast radius when we go into the distributed gateway world. Now with this distributed gateways, you want to keep state on like who is active, who is not. We want to have all of these active. So what we use is something which is in the industry for a very long time, which is Anycast. So we use the closest node, which is there with a given IP address, with a given MAC address. Now, as we are only existing from a classic Ethernet perspective, server to switch, where is my ARP flood going? It's basically stopping here, right? We don't need to flood the whole network there. So with this, we're also reducing the overall network noise, which is down there, if you may so. But it's really about this guy here gets the logic. This guy here will do more than before. And we need to have a couple of things in there that this little guy here can operate in that way. Everyone okay? I guess you heard that for the last 12 months, every second day or something like that. So sorry about that repeat there. But I think it's an important thing that technology which we had for quite some time, and Anycast is not here for 2 days. It is like decades, the concept of Anycast. Reusing it on a MAC and on an IP layer to provide a gateway to a server in a given subnet, in a given VLAN, to a local segment. Move that to the other side. Let's say I have here another black server, server 3. Again, I provide the same IP address, the same MAC address for the default gateway over here. And as I said, if the ARP request gets flooded here, we're not hitting the fabric and then respectively coming in back on that switch. We're staying here local, answer it local. Same thing happens for S3. If he ARPs, he stays local, get a local response. What are we doing in the backup here? We're using a control plane. We're using a BGP-based control plane. It's called EVPN, Ethernet VPN. With an Ethernet VPN, we transport not only the IP information as a routing protocol normally would do, we actually use it as a reachability protocol. We use it as a reachability protocol for MAC and IP. And on top of that, as EVPN itself is actually similarly working like VPN v4, VPN v6, just in addition to the MAC address, we have all these multi-protocol BGP VPN features included. So how many sessions do I actually have from this leaf switch here to my, let's say, route reflector spine up here? It's exactly one session and all the different address families getting transported across. So if I have 5 VRFs here, or if I have 1 VRF here, or 10, it doesn't matter. It's just a matter of local configuration. But from a BGP control plane, we're completely stable. We're not going to increase the configuration part on top of it. Now, as I unveiled a little bit the EVPN space, I have a little bit of another topic, and I know some of you guys were here in 2012, I think it was, when Victor Moreno was talking about a multi-protocol gateway. So we're doing something like MPLS on one side, something like VXLAN on the other side. Or we're doing VXLAN on one side and Lisp on the other side, but all of this in one single box. Now, actually, it's 2016, right? We should have catched up on these vision he had back in the 2012 kind of network field day, as I remember, and actually that vision is here. So today, what we can do in such a VXLAN EVPN fabric, we are able to take the EVPN address family and expose the IP portion into a layer 3 VPN, regardless if IPv4 or IPv6. So this means if I have some smart border node here, and I draw it big, because we want to sell big boxes there, we can actually hook into the route reflectors if you're using iBGP. We're using a VTAP on top of this here, and out in the wild world, we can actually do, as said, MPLS L3 VPNs. We can do Lisp, or we just do something very simple, which is VRF Lite. So when you think of this and add a couple of nodes to the left-hand side, you can build quite nasty networks from one control plane information and the other control plane information while splitting the data plane at the border. So not VXLAN end-to-end. We stop it over here. I know it's a little bit a crazy step from talking about IRB going into a little bit of what we do in the border, but I promised it in my abstract, so I want to give you some glimpse into that. Any questions there?
So your edge to core over here, I'm just going to use the
Yes.
historical terms just to identify, I guess, your layer 2, layer 3 to your layer 3 specific devices, the ones up.
The one here?
So you have basically a pretty broad ECMP selection there.
Yes, I use a wide spine. I use ECMP equal cost multipath. I use IP address-based routing in there, and I can use whatever flavor of routing protocol you like. OSPF some advantages, ISI some other advantages, or if you like BGP that much, iBGP or eBGP can also play in that role itself. On top of it, we anyway use BGP for the transport of EVPN, and to be very specific, it's multi-protocol BGP. And with this, you can build your complete network virtualization abstraction on top of our physical switching gear, with also some adjacent integration into our virtual switches.
What about auto configuration? So comparisons are NVIDIA, so I don't want to compare you to. We've just come from Dell where they can just plug all the gear together and then it auto discovers. And they have a software tool which then takes all the auto discovered information and then automatically configures the fabric.
Yes.
And does all that work for you. Are you into that as well, or moving in that direction?
Yes, we started, I think it's 2 years ago, with certain projects in that direction. We have power and auto provisioning on our boxes for a very long time. We use power and auto provisioning, which is kind of a pixie boot process in there.
Yep.
We're having software components on the Cisco side, which we're providing this. One of them is an open source project, which is called Ignite. Another project, which we're having internally as a product, is Data Center Network Manager. Both of these products are covering certain pain points in network optimization. As Jeff explained before, Puppet, Chef, Ansible are other ways of doing that configuration automation as well. But for this day zero operation, we can basically give you a completely templated configuration today, and you can ship that into the switches and make them ready. And on top of that, the day one configuration, your VRFs, your VLANs, whatever you want to map into this fabric itself, can be automated as well. And also there are various projects we're having in there. And if you're tired of doing this all in this more of Lego box kind of approach, there is another project within Cisco which is very, very well known, which is ACI.
Yeah, ACI is a step in this direction as well, of course.
Isn't there another tool though to add, overlays more easily in this topology? Is it VTS or something like that? A controller-based platform?
Yes. So I was discussing before, we have the underlay management system or the day one management systems in Ignite or DCNM. And then on the top, specifically for service providers and NFV environments, we have the virtual topology system. The virtual topology system itself also provides a virtual forwarder. It's kind of a VTAP, which points into the EVPN story, which can also do L2, L3 forwarding there. Yes, we also have that piece presently in our portfolio, yes.
I wanted to ask about, you made a statement early on that you need to get the custom silicon, the Nexus 9000 with the extra silicon and the F3 modules in the 7000.
Yes.
Is that because the chips that are in there can't do VXLAN tagging, or is it some other magic?
Okay, so the Nexus 7000 today has a series of line cards started with M1, went into M2. We also had the more fabric-facing ones with F1, F2. F3 is the latest silicon we have there currently available, and subsequent silicon will be available as well. The F3 line card at the time where that ASIC was being developed was basically cutting edge or leading edge, to be better, in regards of encapsulations, and is able to do that multi-encapsulation gateway as well as VXLAN. When we're looking at then VXLAN finally got finished from the header definitions and everything, we see that that aligns about when we developed the ASIC for F3.
And the Nexus 7000, because it's 9000, because it's got Broadcoms that do VXLAN termination. Why would I need the custom silicon to do this? Okay, that's a very good question. So today, Broadcom Trident 2 is very common in the industry, and it's an awesome VXLAN gateway chip for layer 2. Today, when I want to go into the layer 3 operation, meaning having from one VLAN to the other and inter-VXLAN routing, if you want to call it this way, I have to either do some recirculation or do some additional magic in there to make this possible. We, in the Nexus 9000, use a Cisco ASIC in addition to the merchant ASICs in there to accommodate this specific operation. And we just decided to do this also to leverage the same hardware on the other project, which I mentioned with ACI. Yes. Static pipeline in the Trident can only strip a tag once. If you're stripping the tag and then you've got to put the tag back on, you're out of luck.
Yes.
There's only so many actions it can take before the chip runs out of depth.
That's correct. That's correct. I mean, still, even with using merchant silicon, I mean, Cisco embarked that project quite some time at the Nexus 3000, where we started with. In the meantime, we are 3100, which is a T2-based platform. We're going further with merchant-only platforms. We will have them. But on the other side, we will still work on Cisco silicon on our own. There are gaps between what a merchant and what a specific or a custom silicon does, and we still have a lot of knowledge in there, so we use it and bring new things out into the industry, also new innovation into the industry with this silicon.
I've only looked at VXLAN with EVPN on the 9K, but I'm assuming the configuration is pretty similar. Are there any efforts to simplify, like when you look at the BGP table for like the /32s, you don't actually see a V4 prefix, you see some MAC address and ops guy is not going to know what to do with?
Can I get that in Britain?
Yeah.
Yes, we're doing efforts to simplify A, configuration, B, outputs, troubleshooting operation related things. When you look at what EVPN is, it's an address family out of this whole IETF construct, and I don't think we will change what a standard BGP output will show. But we will provide respective CLI or structures to make operation much more simpler and also configuration much more simpler.
Well, that brings up another good point. Is there any conflict between running MPBGP for VRF Lite or MPLS on the 7K and then laying this on top as a different address family?
That's a very good question. No, it's not. So neither on the Nexus 7000 nor on the Nexus 9000 or 5000 or 5600 to be very specific. We can run VRF Lite. We can run EVPN at the same time. When you want to have such a switch and be the border of your fabric, you want to fade it out somewhere to the rest of the world. So VRF Lite is probably the predominant way of doing this in a routing handoff manner. So yes, you can run that. On top of that, 7K, as said before, VPN v4 for MPLS or VPN v6 for MPLS will be there as well as subsequent works, which we're going to do.
Can you comment more on Ignite, what that tool is all about?
Ignite is generally a power and auto provisioning engine. It's an open source project. I think it is on our GitHub repository.
Yeah.
And it's focusing on day zero operation. You bring your switch in, you basically discover it based on link role where it exactly is, and then you can bring up the fabric with the respective configuration you want to have on top. I sent out a link on Twitter earlier about this Open NX OS and programmability booklet, or whatever you want to call it, we wrote. Ignite is there also explained in a chapter in the automation piece there. All right, we went a little bit from VXLAN EVPN to automation and management tools and ASICs and left and right.
Sorry.
No worries, it's a good discussion. Thanks a lot. And any more questions? Yeah, Greg, you're out of tickets, sorry. I'm just joking.
Yeah,
I'm just joking.
the question here is, it always strikes me, these overlays and things, a lot of customers have been doing the spanning tree thing, which is often very simple, very direct,
Yeah.
but with problems, right? The blast radius, the weakness, the brittleness, and so forth. Are customers reacting well to the VXLAN EVPN? I mean, I like the VXLAN EVPN story. I've been deploying it for 2 years now. I've seen different vendors' implementations, and I understand the weaknesses and the strengths to some extent between them. Are customers really getting on board with this now? Are we seeing momentum, or is it still
No, it's
in the future?
It's a good question. So it's very, very interesting how much momentum we see on the VXLAN side general, and then on top, when you have initial conversations about flood and learn, which is the RFC implementation of the encapsulation of VXLAN itself, and you point them in a direction of EVPN just because of layer 2 networks is not everything. You sometimes want to have an L3 hop somewhere, and multi-tenancy is not everywhere, but people are asking slowly in that direction. What can I do, or can I make my network ready? So it's a lot of discussions we're having. There are a lot of implementations already running. So we see, I would say it's 75% EVPN versus 25% VXLAN flood and learn.
Okay.
And the flood and learn ones are normally the early starters, which already did some classic implementation in a multi-vendor kind of environment.
Okay.